Hello, Mr. Ryan, right?
Hey.
Okay, so last week we talked about remove the duplicates from a sorted list. We're given this sorted list and then we want to remove the duplicates, so the linked list with the unique numbers, right? And we talk about a few solutions. The obvious solution is to convert it to an array. Once we remove the duplicates from a sorted array, then we can convert it back to the linked list. Or the other way is that we just use two pointer, right? Current and current.next. Every time we check if the next element has the same value as the current. If it is, then we remove this current node by pointing the current next, right? The current next would be points to current.next.next, right? And then we move two pointers towards to the end. This is O(n) time and O(1) complexity. You mentioned this approach, you're using the notebook hash set to remember, to remember the nodes we have seen. This is more like a general approach. It works if the array, if the linked list is not sorted. Does it ring a bell?
What was it?
Yeah?
It's in the corner. My picture down.
Okay.
In the corner.
Okay, so here, look, this is the previous lesson, right? We have to check if the linked list is empty or not. If it's empty, then we simply return, we do nothing. Current node equals the head, because the first node, we can always return the first node, right? Because the first node can be always part of the return linked list. If we have a next element, and we always compare two elements, right? If this element equals to the next element, so if look, this is 1, this is 1, right? This is 2, okay? So this is current, okay? This is current.next, alright? The key thing here is that this is current.next. Look, 1 and 1, this is unique. So we need to get rid of this 1, right? So how can we get rid of this 1? We just point to current.next. Current.next is originally points to 1, right? So we have to repoint it to current.next.next. Okay, and then we can get rid of this. If it's the same, we just move these two pointers towards the end. Okay, so today we're going to implement this using the hash set, using the notebook. Yeah. Okay, so let me write the code. We use the notebook to remember the nodes we have seen. Okay, so this is quite similar. If not head, then we return none or return none. Return none is basically the same as return. Okay, define remove duplicates. We're given this head. Scene is set. We use a hash set. This is like a notebook. Current equals head. Previous at the beginning equals none. Why do we need the previous? So
It's raining hard, heavily.
okay, it's raining. Okay, so look at this one. So this is slightly different, right? Now look at this one. This is 1. So this is previous. This is current. If this current value, we have seen it in the hash set, so then we can say previous.next equals current.next, right? Okay, does it make sense here? This is the key thing today. If this current, we have seen it, we have seen it. So 1, we have seen it in the hash set. So we can just point it to previous.next would be the current.next. It's basically the same thing by using the hash set, okay?
Are you sure you should use a mask?
Yeah, I'm gonna throw that away anyway, okay? So then we say wire current. If it's current of value, we have seen it in the scene table. We have seen this value, previous.next equals current.next. And if we haven't seen it, then simple. If we haven't seen it, then we'll put it in the hash set, right? Put it in the notebook. So scene.add current.value. Okay, and then we have to update the previous. Previous then equals current. Okay, in both cases, we need to advance the current to the next element. Current equals current.next. And then return head, because we haven't changed the head. So for example, like 1, 1, 2, 3, right? The return result will be 1, 2, 3. You can return this 1, 2, 3, or you can return this 1, 2, 3. It doesn't matter, right? These 2, 1. So it's easier if we can leave the first head untouched, because we are only returning the unique elements in a sorted list. So the first node, we can just keep it. We can just remove the second one, for example, in this case, instead of removing the first one. It's the same, right? Look at this simple example, right? 1, 1, 2, 3. We can return 1, 2, 3, or we can return 1, 2, 3. We can always return head, right? Because the head is not changed.
Use
Okay, so what's the word to replace untouched?
No, it's just that you don't really say untouched.
Okay, so correct me. Can you say?
No, it's not wrong. It's like the first time I ever heard you say untouched.
Can you teach me some really good British English?
No, you don't give a point. I'm not saying it's wrong.
Okay, then if it's not wrong, then it's good in this case. Okay.
Yeah, but I'm just saying it's like the first time.
Okay. Oh, another pitfall here is that.
I never heard you say that.
Another pitfall here is that we store the current of value. Yeah, we compare the values instead of current. So, because if we replace this current of value with the current, if we store the node rather than the value in the hash set, then there will be a problem because each node is different. Look, this node, if we store the notebook, right? If we store the node itself, the object itself in the notebook, the first node, the first one, and the second one is different. In the notebook, it's different. Okay, because it's a different object. It's a different object at different address. If we store the node itself in the hash set, then this algorithm will not work. We have to store the node value because 1 is the same as 1. Okay, we have seen this 1 before, but the node is different. Okay, so does it make sense? Yeah. Okay, now let me repeat.
Why?
Let me repeat. We keep tracking of the previous node. What's previous node? Previous node is the node before the current. So why do we need to keep tracking of the previous node? That's simple, right? Let me do this again. 1, 1, 2. Okay. So look, in this case, here this is previous. This is current. Okay. So look, now we are checking this one. This one we have seen it before, right? Because we have put this one in the hash set, the value, not the node. Okay. So now we have seen this before. So what do? So we need to remove this one node, right? The second one. Then we need to point the previous to next to the current to next. Okay? Previous to next, current to next. And then eventually we're going to remove this. So here the same, right? Because look, previous to next equals current to next. So then we can say no, similar here, right? No equals current, right? Here is current. And then previous to next equals current to next. We don't need to keep the current node, then we can delete the node. Okay, make sense? The time complexity is O(n). The space complexity is O(n) because we're using the
set.
Okay, that's it for today. Bye bye.